This is Ben McGahey with Yamie Chess. I'm going to be your math teacher today. Yamie Chess is the math learning aid based on classic chess that helps students in math and science education for school. In this lesson, we will learn about 6 different sets of numbers, of how to classify numbers into their sets. The first set that we will look at is called the whole numbers. And we'll use the letter W to represent the set of whole numbers. So that's going to equal 0, 1, 2, 3, etc. So notice that we started at 0 and then we counted by ones. Went 1, 2, 3, and then 4, 5, etc. So those are the whole numbers. And the second set we'll look at is a set of integers. This is represented with the letter Z. And so that's going to equal the set of the whole numbers and their opposites. So notice that we'll have the 0, the 1, the 2, 3, etc. And then the opposites are the negative numbers. So the opposite of the whole number. So -1, -2, -3, etc. And so the whole numbers were the 0, 1, 2, 3, and so on. And then the integers were like the whole numbers in their opposites. So include the whole numbers, 0, 1, 2, 3, etc. And then also the opposite ones, the -1, -2, -3, so on. And then the third set we'll look at is the set of natural numbers represented by the letter N. So the natural numbers are like the whole numbers except it does not include 0. So we'll just leave 0 out. So we'll just have 1, 2, 3, etc. So the natural numbers are like the whole numbers except we do not have the number 0. And then the fourth set that we see is called the rational numbers, represented by the letter Q. And so the rational numbers are kind of like contains pretty much all of these three sets here: the whole numbers, the integers, and the natural numbers. So it includes the W, the Z, and the N. But it also includes fractions. So basically, if you have a ratio of two integers, like 3/4 or -1/2. And it also includes repeated and terminating decimal values. So if you have the number like 0.1111, repeating, or you could write this as 0.1 with a line above the 1. So that's also a rational number. And then a terminating decimal, say like 5.6. So those are rational numbers. Now the irrational numbers are numbers that are not rational, and they're represented by the letter I. So not rational. So basically, irrational numbers, they can't be whole numbers, they can't be integers, can't be natural numbers, nor can they be rational numbers. But they're basically can't be written as a ratio of two integers or like a fraction, like 3/4 or -1/2. But a good example of an irrational number would be the number pi that's used when you're dealing with circles or spheres or any geometric object involves something circular, round. So pi is about 3.14159, etc. So there's a bunch of digits that come after it. It's just a decimal number that doesn't have a certain pattern to it, and it's non-terminating. So the non-terminating decimals So non-terminating decimals are good examples of irrational numbers. Now the real numbers, the last set, is basically a set that contains all of the other 5 sets. So basically all of these sets together. So we have the whole numbers, the integers, natural numbers, rational, and irrational. So it basically includes all of those sets together. So a whole number is a real number, integer is a real number, a natural number is a real number, rational numbers are real numbers, irrational numbers are real numbers. So it's the largest set out of all sets that we have talked about would be the real numbers. So let's see with a couple examples what we can look for. Let's see how we can classify the sets of numbers. So if we have the number, let's say we have the number 4, and we want to classify what sets 4 belongs in. And so 4 would be a whole number because it's 0, 1, 2, 3, 4, etc. So this would be a whole number. The integers, it would also be whole number is also an integer. So we would know this be also an integer. And we know that it is also a natural number as well, because remember the natural numbers are like the whole numbers without 0. 4 is also a rational number because the integers are rational numbers. So that would be in Q. And then 4 is not an irrational number because it is rational. So the only time it's irrational is if it's not a rational number. And then, of course, we know that 4 has to be a real number. So 4, it belongs to the whole numbers, the integers, the natural numbers, the rational numbers, and the real numbers. Okay, so let's look at another example. Let's say I have 0.9. 0.9. So we'll go through our sets here. So whole numbers, it can't be a whole number because we have a decimal. And the same reason for integers, if we have a decimal, it's not an integer. And then the same reason for natural numbers, it can't be a natural number because there's a decimal. So notice that the whole numbers, integers, and natural numbers don't have decimal values or fractions. Now the rational numbers, we notice that there's a terminating decimal, right? So we have 0.9, so that would be a rational number, so we would have Q. It can't be an irrational number since it is rational, so we leave that one out. And then finally, not only is 0.9 a rational number, it's also a real number. And then last but not least, we'll look at another value. Let's say we have the square root of, let's say, 3. And we can calculate the square root of 3, can do that really fast. So we'll just do, we have 3, and then we have square root. So notice that there's a bunch of decimal places that come after 3. We have 1.732, etc. Now remember, there was a teacher I worked with that he said one of the best ways to remember the square root of 3 is the 1732. That year, it was the year George Washington was born. Our first president of the United States, who fought in the Revolutionary War. So 1732, George Washington was born. So 1.732 may be a good way to remember the square root of 3. So you notice that there's not a repeating decimal. It does not terminate. It's actually non-terminating, and there's no certain pattern. It can't be written as a fraction. So we know that it has to be an irrational number. And it can't be any of the other ones, right? It can't be whole number, integer, natural number, or rational, since there's decimal. And then finally, since it's irrational number, we also know it's a real number too, right? Because real number is all of these sets, any of those sets. So the square root of 3 is an irrational number, and it's a real number. Okay, so those are the sets of numbers, and just a few examples to go over, just to give you an idea of how to classify numbers into their sets. Okay, so now I have 6 problems for you to try on your own, and I just want you to determine, which set or sets each number belongs to, because one number may belong to more than one set. So let's see. You have number 1 is 7, number 2 -4, number 3 is 3/5, number 4 is the square root of 2, number 5 is 0.1111 repeated, and then we have number 6 is -6.8. So I'll give you a chance to review, those sets if you need to rewind. And also pause the video to work on the 6 problems, and we'll be glad to go over the answers. Okay, so let's go over the answers. So you have number 7 for the first one. And we know that this one has to be a whole number. It has to be an integer, because whole numbers are integers, and let's see, natural number also for positive integer. And let's see, is it irrational? Is it a rational number? It is. So Q, and then it's also a real number. So it's a whole number, integer, natural number, rational number, and a real number. Okay, so for number 2, we have -4. So this is a negative number, so it can't be whole number, and it can't be natural number, because those are either 0 or greater, and these are positive. But we do know it's an integer because it includes the negatives, so we'll have an integer. The integers are also rational numbers, because you can write as a ratio of two integers. So, and it's also a real number. So -4 is an integer, rational number, and real number. So for number 3, we have 3/5. 3/5 can't be a whole number, integer, or natural number, because remember, those are not fractions. Those are just numbers you count on your hand, either positive or negative, including 0. But we do know it's a natural number because it is a rational number. And pardon me on that. So that would be Q. And since it's rational, we can't say it's irrational. It's either one or the other, and it has to be a real number. So the only two sets that 3/5 belongs to is the set of rational numbers and real numbers. And then number 4 is the square root of 2, which is about 1 point, let's see, what was it? 1 point something, right? So we go to our calculator just to make sure. 1.414. Something. So we notice that this is a non-terminating decimal number. We can't write it as a fraction or ratio of two integers, and it can't be the whole number, integer, or natural number because it's a decimal, and it can't be rational, so it has to be irrational, and it's also a real number for square root of 2. Okay, so then number 5 is 0.1111, or a bunch of ones repeated with a line above the 1. So we had a repeated decimal, and we know with decimals it can't be whole number or integer or natural number, so it has to be either rational or irrational. And we know with repeated numbers or repeated decimal values that it's going to be a rational number, and it has to be a real number. So those are the only two sets it belongs to. It's a rational number, real number. And then last but not least, number 6, we have -6.8. So this is a terminating decimal value. So we can exclude, the whole integers, natural numbers, because it's decimal. So it's either rational or irrational. And since it's a terminating decimal value, we see it as rational number, and of course it's also a real number, just like with number 5, rational and real. Okay, so if you know how to, if you got those right, great job. And let's see if we got the answers here. So whole, natural, integer, rational, and real. And then the next one was integer, rational, real. Then we had rational and real, irrational, real, rational and real, rational, real. So those were the answers that we got for our problems. So if you got all those right, great job. You know how to classify your numbers into the different sets, which is very important when doing more complicated math problems with sets. This is Ben McGahee, and I want to thank you for watching this video on the sets of numbers. And please stay tuned for more lessons on YamieChess.com. Have a great day.